So I have been focusing on Mendelson over this week and the latter part of last week, and I've read all of chapter 4 and a good chunk of chapter 5, and then also some appendices, especially Appendix F, which took a long time. Now, in the case of reading the book, the real reason why, of course, I launched on reading this book was because I wanted to understand, when I was reading in Rudin, Theorem 119. And Theorem 119 reads, there exists an ordered field R, the real numbers, which has the least upper bound property. Moreover, R contains Q as a subfield. It reads fairly innocent, but then, of course, Rudin says, I'll prove it by constructing R from Q. And this construction I found difficult to read because, and now I understand a little more, now that I have delved into reading a different version of it in Mendelson, plus reading all the background that builds up to getting to this point, that, and this is an issue that I see with not just Baby Rudin, but I think all analysis books, is that number systems and then point set topology especially are really books unto themselves, fields unto themselves, and it's very hard for the author to say, well, I'm going to give you a little bit, just enough so that you know, hey, look, you can build R from Q, all right? Hey, when you do point set topology, these concepts allow to make the proofs a lot more beautiful, coherent, and so but then that's where it's nice in some cases. I mean, it's hard to get into it to understand the concepts if you haven't gone deep enough to understand where it all came from. That's just me. I mean, and again, I'm not trying to tell anybody how they should or shouldn't do their program, because I'm just some hobbyist in the random interwebs. But I know in my case, this book is really growing on me because, I don't know, it feels like I'm learning something that is foundational enough that I can use for the rest of my math learning. So anyways, back to, I've been working on chapter 3 problems, and I'll talk a little bit about that after I talk about the chapter 4 and 5 reading. So chapter 4 in this book is Q, rational numbers and ordered fields. And then chapter 5 is really the meat of the thing. This is really where it begins to track or map fairly closely with your typical chapter 1 in an analysis book. And of course, the way Mendelson built it up is really, really thorough. And I like it. Of course, nobody who writes an analysis book is going to want to spend 300 pages on chapter 1. They need to do something else. They need to do like differentiation and integration. But just to give you an example of the sort of things that are in Mendelson that I find very interesting. So a field has something called a characteristic. Now it is also the characteristic of an integral domain, but later on in the book, you take the integral domain and you add more to it, add another axiom to it, and it becomes a field. You can divide, and you can multiply inverses. So x times 1 over x equals 1, that sort of sums. So the characteristic is 0, and if for all positive integers, n does not equal 0. So for example, I can't think of a good example, but for example, in the case of mod 2, it's really the number of ones that you add to get to 0. So the example of mod 2 is relevant. So otherwise, the characteristic is the smallest number of ones, which when added together yields 0. So 1 plus 1 equals 0. So for example, in mod 7, you add 7 ones and you get 0. And interestingly, this whole characteristic business is found in various books, and it's innocently mentioned. And I think if I tried to read this wonderful book by Halmos, Finite Dimensional Vector Spaces, which incidentally is kind of like rewritten by Axler in his linear algebra done right, modernized, done in a way where a modern audience can understand it better. Here's a problem, and I'm not going to zoom in and out because every time I do so I forget to zoom in or zoom out the right way. So I'm just going to keep everything the same in this video. Even though this is tiny font, I'm not going to read the whole thing. I'm just going to mention that in this problem, the characteristic of the field f is defined to be 0 in the first case, which is mod 2, or the crucial prime in the second. Well, 2 also happens to be a prime. So there you have, an innocent mention of the word characteristic, but now that I'm reading this fine book by Mendelson, I have a little bit of an understanding of it. Okay, down to my reading. See, so this is the problem sets. The reading. So in the case of reading, I read all of chapter 4, which was short. So for instance, you start adding rational numbers, multiplying rational numbers. Also going through the properties of a field at some point. Right here, the properties of a field. And then when Mendelson started talking about examples of fields, I just wanted to get back to the axioms, so I rewrote them just to get to home base. Yeah, just to get to home base. So this is a good example where you have an addition table and a multiplication table for a field with 4 elements. You see a lot of this in number theory. So then you start, there's this whole thing of having an integral domain, making it ordered. So you start with d plus product, then you add the less than. Then of course, depending on which number system you're in, these get appended. So it's plus q times q plus z times z. So you know where you're performing that operation, in which system, because of course the integers are not a field. Yet and the rationals are. Then you have the properties of an ordered field. Subfields. See how here the field 0, 1 is actually a subset of a larger field. Then there's a little bit of a discussion of isomorphisms, which in chapter 5 get really deep treatment, and that's actually what I'm reading right now. Then I took a detour from chapter 4 and reading the beginning of, at the end of chapter 4, I went and I read Appendix C on polynomials. And then after I read that, which was not a long read, I came back to reading chapter 5. So that's where it starts to track fairly well with your analysis book. Some of the proofs are actually the same as they are found in Baby Rudin, but I think explained, in my opinion, better. And then this is where I started really finally matching what I came to Mendelson for with what Mendelson is doing. So Mendelson talks about how when you do cuts, you can do lower cuts and upper cuts, but to limit the math and limit the algebra, make the discussion more brief, more succinct, you can only use lower cuts and it works. And that's what Dedekind did. And so in the case of Rudin, he's only using lower cuts. And in the case of Mendelson, in Appendix F, which is kind of like, I don't want to say it's the reason why I'm reading the whole book, but it's one of the reasons. It actually was the beginning reason, and then now it's become one of the reasons now that I've read more in the book. Now, especially since I've learned something like characteristic and all these other things that I didn't know I was going to read, I was going to learn in Mendelson. So Appendix F in this book is really long. It might as well be, it's almost like reading half of chapter 4. And it is the Dedekind construction, right? So there's a whole concept of what a lower cut is, and then trying to proving all the basic theorems for commutative, associative, but with cuts. And it's a little weirder. It's a little weird because the cut itself, so for example, the addition of the cuts A and B, both lower cuts, is a member from A and a member from B added together. And so all these theorems, when you're adding or multiplying these cuts, you're trying to find out which element landed in the product or the sum and which landed lower than that. So there's all these cases, and so there's these cases for how you take negatives and put them in to prove something. So for example, in this case, A and B are negative, and so you put in the negative B, but you have to put in an extra negative because you want to match it to a positive. And that's the basic principle that's used for all the proofs. Again, this is just what I showed, but now I read it. These diagrams are similar to what I showed before when I read chapter 1 of Baby Rudin. Now what I want to do is, after I finish Mendelson, I want to be able to read. I want to read a few chapters in Thomson, Bruckner, and also in Abbott. Then go back and then go through Rudin again with my newfound. I don't want to say knowledge because I'm still not sure that I fully understand these concepts, but at least I have another reference that I can use to flesh out how Rudin did it. And then, of course, one of the things that I'm really liking about chapter 5, where it's paying off for me, is that there are theorems in which cuts are used to prove the theorem. Let me see if I can find an example. See if I can find an example. I think there is one. There is one somewhere in here. When you get down to proving that a field, an ordered field, is complete. Yeah, so I think there was one in here where it talked about there not being a gap. And of course, when you find a gap in your cuts, the field is not complete. Can't easily find it right now. Oh, there it is. So if AB is a cut in an ordered field, then AB is a gap if and only if A does not have the LUB property. I mean, it does not have a lower, at least upper bound. At least upper bound, which is different from having the property itself. So that's where I am so far in chapter 3. And I think I'm at like the 40% point. Now I'll show briefly, started working on problems in chapter 3. There we go. And it's all about rings and integral domains. In the case, there's a problem, problem 7. Let me see if I don't have to page too much to show it. Yeah, I did not have to page too much to show it. And I'm not going to zoom in, because if I zoom in, I'm going to forget to zoom out. So exercise 7, you go through all these examples of sets and relations in them, and you have to show whether it is a commutative ring, which are the unit elements if it has them, and is it an integral domain. And of course, the problem 7 is really like the size of a problem set, and that's what I'm working on right now.